So basically, if we continue with the concept of magnetism, so there is an other concept, or we can say that if we just want to study the concept of electricity and magnetism, so we are going to discuss about electromagnetism.
Okay.
So by name electromagnetism, you already know about that. In this concept, we are going to discuss about the combined effect of electricity plus magnetism, right? Let's
Yes,
suppose
sir.
if we consider a very common basic example, and if we are having a conductor, and from that conductor, charges are moving from left to right, let's suppose in this direction. So you know that when current passes through the conductor, so there will also be a magnetic field generated around the conductor, right? So let's suppose
Yes, sir.
we want to mark the magnetic field. So we will get the magnetic field around the conductor. Okay. So the problem is that we have to identify the direction, and we have to find out the direction of the magnetic field also, right? So basically, we need to know about some basic or some like the logical rule that will help us to find out the direction of magnetic field with the direction of electric current, right? So
Yes,
the
sir.
first thing that we discuss is when current when current is passed through any conductor. So magnetic field will generate around it. Around the conductor. So this is the basic concept that always there will be a magnetic field when current passes through any conductor. And the second important thing is we have to identify the direction of electric current or and the direction of magnetic field, and what is the relation between the direction of electric current and the magnetic field. So let's suppose if we consider two situation, right? If we consider two simple straight conductors, and if we consider the straight conductor means that conductor is a straight wire or a simple straight rod or anything. So first we need to identify the direction in that case. Then we will discuss with some advanced application, like if we are using a circular coil or conductor is not a straight one. So what will happen in that case, right? So let's suppose first of all we are taking example of a conductor, and basically there are two possibilities. First possibility is either current will move in upward direction, and second possibility is that current will move in downward direction. Okay. So there are two possibilities in a straight wire if we are using conductor in vertical form. So now, first, if we consider the situation when current is moving in your direction, so your magnetic field will generate like this. So basically, if current is moving in upward direction, so your direction of magnetic field will be like anti-clockwise, right? Now, because you can see the direction of the arrow, so that shows you anti-clockwise rotation, okay?
Okay. Okay.
And in second term, when current is moving in downward direction, so definitely your direction will be opposite to the first one. Now we are getting clockwise rotation, okay? And what is the logic behind it, how to remember this situation? So that is a very simple concept. We have to use right hand grip rule, right?
Yes.
So basically in right hand grip rule, if you consider any pen or pencil in your hand, let's suppose that was a conductor, and when you hold that pencil or pen uh, firmly, so now consider your thumb. So basically that thumb indicates the direction of the electric current, right? And the fingers that are actually curled around the conductor, so that will give you the concept of the magnetic field, right? So basically right hand grip rule indicates you the direction of magnetic field around current carrying conductor. So if you try to hold any pen or any pencil just like the conductor, so that will give you the concept that in which direction the current is actually moving. Let's suppose if you consider this diagram, so you can see that in this diagram that we just hold conductor, or we just grip any conductor in our hand, and according to that situation you can easily identify that your thumb actually indicates the direction of electric current, right? So thumb actually indicates in the direction of electric current, and the curl of the finger actually shows you the direction of magnetic field, right? Because magnetic field is in circular form. And if your current is moving in downward direction, right, so you need to turn your hand in inverted position like this, so you can see definite direction will be reverse, okay? So now in first condition current is moving like anti-clockwise direction, and in second situation current is moving in clockwise direction, okay?
Okay.
So this is the concept of right hand grip rule. And in our exam we know that we are not able to make the 3D diagrams, so there are some different terms, there are some different concepts that we have to discuss also. But before that, let's suppose in right hand rule thumb is important and curl of fingers are important. So basically thumb indicates the direction of electric current, and the curl of finger actually indicates you the magnetic field, right? And as I mentioned that in our exam, we are not able to draw, or they will not ask you to draw the 3D diagrams in your exam, right? So there are some other terms that we used in our exam. So that will also cover the concept of the z-axis, because on paper we can easily draw x-axis, y-axis, we can easily identify them, we can easily draw diagram on that. But for z-axis, we are not able to complete that diagram like the normal one. So basically for that purpose, we are having a concept of into the page and out of the page, right?
Okay.
So the concept of into the page and out of the page will be like this. Let's suppose if you consider the example of the bow and arrow, right? So if you observe that arrow, so arrow is like the pointed one from the front, right? And there is a cross section type area behind that arrow, right? Like this. If you consider the first dot, so basically that actually looks like the front part of the arrow, right? And in the second circle, you can see there is a cross. So basically that cross represents you the back side of the arrow. Okay. Like this. So if you consider the front side, so that will be the pointed one. And if you consider the tail of the arrow, so that is like the cross one as mentioned in the second part. So basically, let's suppose if you take your pen or pencil, right? And if you place your pen or pencil with the tip of the pen on your paper, right? Or on your screen. So basically, you are thinking that your pencil or pen is moving into the paper, right? Let's suppose if you take the paper and you just pass the pen or pencil through the paper, right? So basically that represents you that pencil or pen is moving into the paper, right? Any confusion?
No.
So basically when you pass your pencil or paper pen through the paper, so you are only able to observe the back side of the pen or pencil, right? Like the tail side. Okay. And if you
Okay.
reverse the process means if you take paper in front of you and now you try to pass pencil or pen from the bottom of the paper, right? So when pen or pencil just penetrates into the paper and pass through the paper, so you observe the pointed side of the pen or pencil, right? That is coming out from the paper. Okay. So when something is moving towards the paper, so that is the concept of into the paper. And when something is coming out from the paper, right? So that gives you the concept of out of the page or out of the paper. Okay. So basically, this pointed side shows you when object is coming out from the paper. So we can write this concept as out of the paper. We use dot point for out of the paper concept. Or let's suppose if you consider another example like this, if you consider the example of this arrow. So when you just target this arrow in front or on any other target, like something is in front of you and you just release this arrow in the direction of the target. So when arrow is moving away from you, right? So you only observe that backside of the arrow, right? The tail side.
Yes, sir.
And when arrow is coming towards your direction, so you are able to observe that pointed side of the arrow, right? So that is the same concept of into the paper or out of the paper.
Okay.
Into the paper or out of the paper or page, both terms will work. So basically if we consider a paper, let's suppose, so basically in your exam they used to mark these points or cross in your exam. So let's suppose if they consider any example of the conductor that we are working with the help of paper. So with the help of paper, they give you the marks like this. So you can easily identify that this point represents out of the paper example. And the second one is into the paper. So this is the concept, right?
Okay, sir.
Further, if they ask you to draw the magnetic field around it, so let's suppose if we consider the example of out of the paper and we have to draw the magnetic field around it. So basically, you know that when we are going to mark the magnetic field around that dot, so basically that is out of the paper. So out of the paper means now you have to place your right hand on your paper, right? And thumb should be in vertically upward direction, like thumb is facing towards you, right? And finger is actually curled. So what will be the direction of magnetic field you are getting?
Sir, it would be clockwise.
Like this.
Yes,
Because
sir.
example is out of the paper, so out of the paper means you have to place thumb in upward direction, right? Like if you place your right hand on your table, right, so thumb should be in vertical upward direction. Okay, now you will get your finger curl, so that finger curl will be like anti-clockwise direction. Okay, and one more important thing, that when you are drawing these magnetic field, so always remember, as far as you move uh, away from the conductor, so magnetic field will be weaker, right? We also discussed this concept in magnetic field, because when we are close towards a magnet or when we are close towards the conductor, so your field will be strong. But when you are moving away from the conductor or the magnet, so your field will be weak. And with the reference of the diagram, we can identify this concept with the distance between the field lines, right? Like if you observe in this diagram, so you can see that there is a certain distance between these lines, right? So now if you draw another field line, so that will be like at a more distance as compared to this distance, right? Or this is more larger one, we can short it down. Okay, so now you can see that your distance is actually increasing, right?
Yes, sir.
So basically it shows you whenever you are moving away from the conductor, so your magnetic field will also be weak as compared to
Will
the,
be weak.
yes, so basically that
Compared.
is the concept. So in your exam,
Okay.
so basically in your exam they will ask you in MCQs, so that how to represent the magnetic field. So this is the concept in your exam. So sometime we just quickly take the reference of right hand rule and we just take the answer, but we forgot to think about it that the distance between the magnetic field is also important. So we have to also cover that point, right? And secondly, if you consider the second situation, like the example of into the paper, so in this concept you can again see distance is actually increasing, right? And if you want to identify the direction, So now thumb should be in vertical downward direction because we are using into the paper concept,
Okay.
and your field will be clockwise in direction, right? Any confusion?
No, sir.
So this is the concept. So basically in your exam, have to remember some important points. The first one is because in your exam they sometime ask you to draw the magnetic field line, so you have to draw concentric circle. So they will award you marks for the concentric circle, all circles having the same center. And the second thing is
Sir, what is the concentric circle? Can you explain again?
basically as you can see, we are drawing a circles around a single conductor, right? So
Yes.
basically your circles will be like this, because I also used to draw with free hand, because in paper you are not going to draw with the compass, it is not compulsory, right? So if you draw with the compass, so definitely these circles will be perfect. Concentric means that the center of all circles will remain same, right?
Okay. Okay.
So you have to choose the center as the conductor as the center of the circle, and then draw with the reference of compass, right? So all circles will be perfect. And the second thing is increasing gap between circles. This is most important point because we sometimes forgot this point. And the third important thing is you have to identify correct direction. So these are important points you need to remember whenever you are going to mark your diagram in your exam, right?
Okay.
So this is the thing that we discuss for a conductor in a straight line. But let's suppose if we are having a circular coil, right, which is known as solenoid. So in that situation, your current will move in circular direction. So then we are not able to use this into the page or out of the page concept like this. We have to make some changes, or we have to modify our right hand grip rule. So let's suppose if we start with the concept of the solenoid. Solenoid means
Coiled string.
yes, it is just like the example of the spring, right? So basically, if we are using a wire with the circular path, so now you can see that in this concept, current is also moving from positive to the negative, because the direction of current will always from positive to negative.
Sir,
Now,
why would it be like that from positive to negative?
basically, there are a concept of, we will also discuss that concept in current electricity section. Basically, electrons are only free to move, right? So, and protons or the positive charge, we consider them in the nucleus, right?
Yes.
So we are not able to move the positive charge because they are in the nucleus. And if we try to move the positive charge, so your solid will deform, right? Because your structure will break down. So that's why we consider positive charge as a high potential and negative charge as a low potential. And you know that in our daily life concepts, everything will flow from high potential to the low potential. Okay. Just like if you take the example of the ball, when you place your ball on any slope, so it will automatically roll down, right? But it will never move in upward direction by itself, right? So
Okay.
that's the concept of high
Yes.
potential and low potential. So that's why we consider the direction of electric current as the convectional current from positive to negative one, right?
Okay.
And they will also ask with the reference of negative charge that if current will flow from negative side, that is also known as electron flow, right? So that negative
Yes.
concept shows you the concept of electron flow when electrons are going to flow from one point to another. So that
Okay.
is the difference. So always consider current from the positive to negative direction unless they ask you about electron flow. Okay.
Okay.
So we are working with a coil, right? And in this coil, we are not able to apply that right hand grip rule just like the same as we already discussed, but still we have to identify the direction of magnetic field. So basically we will get magnetic field like this, but how to identify, that is the question. So let's suppose, so this will be your magnetic field.
Sir, what does the I stand for? Is it current?
Yes, that is for electric current.
Okay.
Right, so this is the pattern of the magnetic field that we have to identify for any circuit or any coil in your example, because we have to know about the directions, that what directions are important that we have to draw. So this will be the pattern of the magnetic field around any coil, right?
Okay.
And in this situation, you can see that your magnetic field is like not the circular one. Your magnetic field like is now a linear radially one and only circular at certain part. Okay. So how to identify this example? So let's suppose if we consider one diagram. So in this diagram, you can see that, right? Now we have to hold the conductor like this. Okay, so basically we are talking about the circular coil that is the solenoid, right? And in solenoid, you can see that there is a coil which is completely wound on a conductor or any rod, right? And current is passing through that coil or that wire. And now
Yes, sir.
you see that current is it starts to move from this direction. So this will be the positive side and this will be the negative side. So actually the problem is current is starts to move in a circular path, but it will change its direction. So that is only the problem, right? So we have to identify the direction of magnetic field. So now we have to modify our right hand rule or right hand grip rule. Now we just shift the quantities, like we use thumb for the north pole, as you can see. Now thumb represents the North Pole because we have only thumb, so we can only identify one pole at a single time. We are not able to identify both poles, right? And secondly, the curl of the finger actually shows you the direction of electric current because electric current is circular. Magnetic field is now the linear one at this moment. So in this way, we can easily identify the direction of the magnetic field and the electric current. Okay. by using same right hand grip rule but with different orientation. Okay.
Okay.
So let's suppose if current starts to move from left to right, like positive will be here and negative will be here. So definitely your direction will be changed, right? So then your thumb will be towards right hand side over here, right? And your fingers will be in upward direction. So that will give you the opposite concept of the coil. Okay. Clear? Any confusion?
No, sir.
So basically, in the case of the solenoid, we are using the same right hand rule, but with different orientation in the sense that this time we are using our thumb. So with the help of the thumb, we can identify the direction of the North Pole only. And you already know about the concept of magnetic field, that magnetic field will move from north to south. So that's why it will be radially outward for the north and it will be radially inward for the south. Okay. And curl of the finger shows you electric current. Okay. Any confusion? Okay, now if we consider another important case that usually asked by the examiner in your exam, that let's suppose if you have two conductor or two straight wires or two straight conductors very close to each other. Okay, let's suppose if we consider two conductor like this, I will give you example. Okay, so these are two conductors, correct? And in these two conductors, let's suppose if we consider the direction of electric current in upward direction, like this will be the direction of current and this will also be the direction of electric current. Okay.
Okay.
So basically, in these two conductors, you can see that current are moving for both in both conductors in a same direction, right? So basically, magnetic field will generate around the conductor, right? Let's suppose if we consider for the first one, and since the direction of current is same for both conductor, so you will get the same direction of magnetic field in both the conductors, right? Like this, correct?
Uh, yes, sir.
So the main concern is because in your exam they used to give you 2 points on the paper that these 2 points shows you current into the paper or out of the paper. Now try to identify the direction of magnetic field. What will be the direction of magnetic field? And what do you think that these conductors will attract towards each other or repel each other? So what do you think in this situation when conductors are close to each other and current is moving in upward direction? So these conductors will attract towards each other or repel away from each other. Magnetic field, electric current, both are mentioned in your diagram. You just need to answer that that these conductors will repel each other or attract each other. What do you think?
So they attract each other.
They will attract each other because they have same magnetic field, right?
Yes, sir.
So the first important point that we identified, when we are having like direction of electric current, so they will attract each other, right? And if we consider the unlike direction, like if current is moving in downward direction in one conductor and in opposite direction in the other conductor, current is moving in upward, current is moving in downward direction. So in this scenario, you can see that current is like in opposite direction. So in another current, they will repel each other, right? Because if we just mark the magnetic field, so this will be for the downward one, and this will shows you the direction of magnetic field for the upward current direction. Okay.
Okay.
So basically you can see if you consider the example of the gears, or if you take the example of the wheels of the motors or gears in the motor, so if their rotations are opposite to each other, so definitely they will stuck, right? They will further not move. And if they are moving in such direction that they will support the rotation of each other, so then your motor or your rotation will continues to move, right? Otherwise they will stop over there. Okay.
Okay.
And further, if you consider the example of the conduction, so basically in conduction we can say that let's suppose if we consider two example with into the page and out of the page situation.
Okay.
So let's suppose if we consider into the paper situation, this is into the paper, this is also into the paper. And if we want to mark the magnetic field around it, so this will be magnetic field. Okay. Now when we are going to make an other field line, right? So they will like interact with each other. So we know that there is a force of attraction. So definitely their field will also combine. Okay, because they will attract each other.
Okay. Okay.
So this will be the field direction, right?
Yeah.
Or we can make it closer like this. So basically this shows you the direction of the magnet field. And we know that this is the situation of out of the page or into the page.
So it's out of, so it's into the page.
Into the page. So into the page means this will be your rotation, right?
Yeah.
And simply mark these lines on the upper field lines like this. Okay. So this will
Okay.
be the direction of the field lines when two conductors are close to each other, because in your exam they used to ask about it. But if we consider the opposite direction of electric current, like if one is into the paper, second one is out of the paper, so in that scenario we can say that their field lines are opposite to each other, so definitely So they will repel each other, and their field lines are like this, because they are going to repel each other. Okay.
Okay.
And you may follow the same direction, but pattern will be different. You can see on left hand side it is into the paper, so again clockwise rotation. For out of the paper it will be different direction, and this will be the direction for a straight line, right, which is moving in downward direction, because from left and right both are moving in downward direction. Okay, clear? Any confusion?
No, sir.
So this is the concept of electromagnetic concept related to the current in a straight conductor, right? And let's suppose if we consider few examples, and let's try to figure out that how this will work actually in your questions. Because most of the time you got the question from electromagnetism, because simple magnetism, simple electricity is not like very difficult one. So that's why electromagnetism. Okay, so there are some questions related to electric motor. So we are not going to solve that one right now. We only studied about the concept of the conductor and the magnetic field. So first of all, we consider the question from that thing. So the diagram shows the magnetic field around wire X, which carries a current into the paper. So you can see they ask with the reference of into the paper and out of the paper. So the arrow on the field lines show the direction of the force on.
So it shows the first force on the North Pole.
Okay. So the arrows on the field line shows the direction of the force on a north pole, right?
Yeah.
And question number 10.
P and Q represent two parallel uh, straight line straight wires carrying currents into the plane of a paper. P and Q exert a force on each other,
Hmm.
which arrow shows the force on Q.
So basically, in this situation, P and Q represents two parallel straight wire, right? The same thing that we were talking about. Okay. That
Okay,
when
okay.
conductors are close to each other and their fields are like opposite or same. So basically, now you can see in both conductors, the case is of into the paper or out of the paper.
It's into the paper.
Into the paper. So now both are into the paper. So basically, they are asking which arrow shows the force on Q. So let's suppose if you consider this diagram that we discussed, right? So if you consider this diagram and with the reference of this diagram, what do you think that what will be the force that they will towards each other or away from each other? So basically, this will be the direction of force, because they are going to attract each other. So that's why we have considered the example that your force must be towards each other, right? Okay,
Okay, okay,
so this is the concept.
okay. So would the answer be D?
Okay, let's check the question again. Yes. So basically,
The
which
answer
arrow shows the force on Q? D,
that
yes,
will be B. Yeah.
right? Because that is in the direction of P, that shows you the concept of attraction. Okay?
Okay.
And further, if we find out the question, yes, this is the question, right?
Mm-hmm. Sir, would it be D?
D. So basically, in D, the problem is that two conductors are in opposite direction in the sense of the electric current. You can see this one is into the paper,
Yes,
this
and this
one
one's
is
out of
out
the
of the
paper.
paper. So that is the problem. So try to figure out some other
Oh, sir, that will be A.
A.
Yes.
Confirm.
Yes, sir, A.
Okay. So basically in A, we consider into the paper direction, rotation is fine, out of the paper, rotation is fine. And in B, there is a problem with direction, right?
Yeah.
So these directions are wrongly marked. And what about option C? Any idea?
Sir, I think that would be wrong.
Okay, so B is actually wrong, D is actually wrong, and A you identify in A direction, and the rotations are perfect over there. And if we consider the example of C, so what do you think that they will give you the same concept or not?
Yes, there is the same concept.
Because we just mark this diagram and you can see all lines are in downward direction, because from left hand side or from right hand conductor we are having opposite direction. So when we are moving in opposite direction, so definitely your field will be like in this pattern. So according to this situation, we can say that C will be the right option, because in A all things are perfectly fine, but the problem is they are not showing the force of attraction, right?
Yeah.
Because these lines are missing in part A. That should be like this, okay? So that is the only problem. Otherwise, A in option A, the direction of electric current and field lines are perfect over there. Only problem is that the field lines are not completely marked over there, okay? And you can see another question related to the same thing. Two long straight wires hang vertically close to each other, the wires carrying current in opposite direction. So one is out of the paper and second one is into the paper. So which diagram shows the magnetic field pattern around the wires? Any idea?
Sir, I think it would be B. Sir, B. Yes, sir.
Okay. So basically in B, the problem is current is into the paper towards right hand side, into the paper. This is out of the paper, okay? And according to that, your rotation are fine, okay? Option A is not possible because they are opposite and they are showing attraction force. Also not possible. And in D, directions are wrong. Yes. So B will give you the
Yes,
right
sir.
answer, okay? So
Okay.
now you can see that with the help of the basic concept of the direction, you are able to identify each and every part of the conductor and magnetic field, right? You can see there are many questions related to the same concept, right? This is the third one
Yeah.
we are getting after question. Okay, consider a 26. So read the question and think about it. There are two parallel wires, okay,
Okay.
and wires carrying current in opposite direction. And three compass are placed in the opposite position as you can see in the diagram. First one is pointing in downward direction, second one in upward, and third one is again downward, right? So they all are opposite to each other. And this actually shows you when the current is moving in opposite direction, right? So you can
Yeah.
see the wires, current is actually moving in opposite direction and the compass actually shows you the real time pattern of the magnetic field, okay? All are
Okay.
opposite. So if you reverse the current in the wire, okay, so how many compass needles change direction? There is no magnetic field, there is no earth field included. So what do you think?
Sir, I'm not sure.
Okay, so basically when the current moves in opposite direction, there will be field of, or there will be force of repulsion. Again, think about this diagram, right? You can see that if you consider this diagram into three parts, like at this point, and if you compare with this point and the second point, and this will be the second point, and in the repulsion case, this is the central line, right? But in the attraction case, there is no central line like the repulsion case, okay? Because they are joined with each other, so they are moving in different pattern, okay?
Okay.
So basically in this situation, when you reverse the current in both wires, right? So basically current in both wires are reversed. So basically when you reverse the current, so your new pattern will be like this. In this wire, current moves in a downward direction, moves in upward direction. So definitely your needles will automatically reverse, right? Because when your direction of current reverse, so then your direction of magnetic field will also reverse, right? So simply your direction of needles in all the compass will change. So there will be three change in the needles. All of them will change their direction because your direction of electric current actually reverse. Okay.
Okay.
So the compass that is actually shown in downward direction, that will be upward, will be downward, and this will be upward, right?
Okay.
Clear? because still they are
Yes.
moving in opposite direction, not in the same direction. Okay.
Okay.
Question number 28. In question 28, the diagram shows three pairs of parallel wires with current in direction shown. In the first one, are moving in same direction, opposite, same direction of electric current. Question is, for each pair of wires, what are the forces between the wires? That is a simple one. So what will be the force in the first case of X? Is it same or opposite? Because when current direction is same, so what do you think that magnetic field will be force? There will be force.
He connected.
Okay, so basically we are on question number 28, right?
Mm-hmm.
And in question number 28, we have to identify what will be the force of, either there will be force of attraction or force of repulsion between X, Y, and Z. So we know that current is moving in the same direction for X, current is moving in opposite direction for Y, and current is again moving in same direction for Z. So what will be the forces between the wires? Attraction, or repulsion. There are four possibilities. So what do you think? So what will be the
Sir, I
force?
think X will be X and Z will be attraction, Y will be repulsion.
Yes, because you know in opposite there will be force of repulsion. Simple, right? There is one more related to the diagram. Again, two parallel wires carry currents in the same direction. Which diagram shows the magnetic field around each wire and the direction of the force on each wire? So you have to identify the magnetic field around each wire and the direction of force on each wire. So what will be your answer? Let's suppose if we consider the first option A. So in option A, current is moving in downward direction. So both wires having same direction. So what will be the direction of magnetic field according to the situation? Their rotation will be fine or not?
Yes, sir, the rotation will be fine.
Yes. And the direction of forces, is it also okay or not? You can see when
Uh, yes,
yes,
sir, direction forces is correct.
yes, because they are showing force of attraction. So option A is fine. Let's check out other option, that why they are wrong. What is the problem in option B? Can you identify the problem?
So the direction of the magnetic field is wrong.
Yes, very good. So the direction of magnetic field is wrong, because if you are able to identify the problem in the question or in the diagram, so definitely you got the concept that what you are actually doing in the question. And if you find out in C and D also,
The
what is the
forces are the wrong.
forces are wrong, correct. And in D again forces are wrong. Very good. So that will give you the concept of the two wires, because there are multiple questions of the same concept. Okay, if we consider some theoretical questions also, in this part we have to discuss about the force on a current carrying conductor, right? Because we are already
Yes.
talking about uh, the magnetic and electric concept. only we have to discuss about the concept of the force in this thing. But before that, let's consider some examples related to the electromagnetism concept. This is also related to the force. Okay. Question number 34 is related to magnetism and electromagnetism. So first read the question. A magnet is placed on a bench as shown in figure. Then and P actually picks it up. As you can see in the second part of the diagram, that rod P actually picks up the magnet from North Pole. And in the third diagram, that point P again picks up the South Pole also, right? So you can
Yes, sir.
identify that P is a rod and it actually picks up the both poles, right? So question is that suggest what material the rod is made from. If you remember, we discussed about some materials, right, in the chapter of magnetism. Can you identify that what type of material we are using in this concept? Because there is a hint in the diagram. So first try to answer, then I will explain you.
Sir, the rod would be made out of soft iron.
Soft iron, why?
Sir, because it can be magnetized and demagnetized easily.
Very good. So basically that is the concept and that is the hint in your diagram that when we place uh, at two different poles, so they easily attract the point P. So it shows you that rod can easily be magnetized and easily demagnetized because it actually attracts both poles, right? So soft
Yes,
iron.
sir.
And explain how the rod lifts each end of the magnet of the bench.
Sir, because when the rod is not when the rod is magnetized, it would lift rod P over.
Hmm. Actually, when you place rod close to the magnet, so rod is like a magnetic material and it can be attracted by the North Pole, right? And after
Yeah.
that, it demagnetized, and when you place that rod on the next pole of the magnet, so it is also attracted by that pole, right? So we can say that. So now you have to write that reason which you mentioned in the first part in your second part, that it can easily be magnetized and demagnetized. So basically a soft iron can easily be magnetized and demagnetized. So when close to North Pole, attracts and become magnetized. And secondly, when we remove from there, it will demagnetize. Okay, so this is the simple concept. Any confusion?
No, sir.
Okay. So in the part B of the question, in first part they are only asking about the magnetic property. In the second part, there are two figures and you can easily identify that they are asking about current into the page, right? Because we already discussed many MCQs and many questions, so now it is not much very difficult for you to identify. So there are two diagrams. The first one is the 3D concept that current is actually moving in this direction. Second one is the simple plain example when you observe the diagram from above. So in the first part on figure 3.3, 34.3, sorry, draw the magnetic field due to current in the wire. So basically you have to draw the magnetic field. So can you identify that what will be the direction of the magnetic field and how to draw the magnetic field lines?
Okay, sir, I'll annotate it on Zoom.
Okay. So if you are able to annotate, so you may annotate, otherwise you may just you have to, yes, that was fine. But you have to mark on 34.3, right?
Oh, okay, this one. Okay, sir.
That's why they
Um,
give you a plain structure. So that will be easy for you.
so like this will be fine.
Yes, but one more important thing, if you remember that a question is for 2 mark. So basically, they will give you 2 mark, one for the direction, correct direction,
Mhm.
because they know you are just drawing with free hand, right? So it is
Yeah.
not necessary to use compass, and there is no restriction. Like in question, they didn't mention that, right? So first of all, you have to draw the concentric circle, and the second mark is for the correct direction. And the third important thing is that if you make the field lines, so that field lines must be close when we are very close to the conductor, like this.
Okay, sir.
So when we are close towards the conductor, so that will be fine. Their field lines are closed, and when you are moving away, so that means field lines are also far away. So this is the direction of magnetic field, okay? And the most important thing, always remember to increase the distance between the field line. That is most important thing. Otherwise you will get only 1 mark for correct direction. And in second part, they automatically ask about the same concept. The magnetic field is stronger closer to the wire. State how the magnetic field lines indicate that the field is stronger. So if your field is stronger, so how you can identify with the help of magnetic field? Can you answer that one?
No.
No. Try to think. That is not very much difficult. Basically, in the diagram,
Sir, is it? No.
So basically, when field lines are close to each other, so that will give you a concept of a strong magnetic field, right? So when field lines that represents the strong magnetic field, right? And if field lines are away from each other, so that will show you the weak magnetic field concept.
Okay.
So this is the thing that you have to write, because in diagram we are working on that. But if they ask you theoretically, so you may answer with the concept of the theoretical concept, right?
Yeah.
So that is the thing.